The life of a star is so violent, so enormous, it staggers the imagination. Our sun, the star closest to us, is no exception. Its raw material is so powerful, just a pinhead's worth could kill someone at a distance of 160 meters. Its visible surface is a fierce churning cauldron of billions of furnace-like cells called granules, each one a kilometer in size. Granules explode, spewing their material into the solar atmosphere at 1,600 kilometers per hour. That's like rocketing over 10 football fields in a second. It's an outrageous understatement to say the sun is hot. The surface is 6,000 degrees Celsius, rising to over 15 million degrees at the core. The enormity of its heat output is mind-boggling. 400 trillion watts. That's 40,000 watts of light from every square inch of its surface. The brightness of 700 standard household bulbs emanating from an area the size of a quarter. Pretty breathtaking when you consider the sun's actual size, 1.4 million kilometers in diameter, 330 times larger than Earth. If it were the size of a beach ball, the Earth would be a pea. And that's just one star amid more than 100 billion in the Milky Way. Next to some other stars, the sun is downright puny. Betelgeuse, one of the stars in the Orion Belt, is a staggering 500 million kilometers in diameter. If it were hollow, the Earth would comfortably revolve around the sun inside it. Alpha Centauri, the nearest star visible by the naked eye, is 4.5 light years away. It would take almost 5 years to get there. If our sun were scaled down to the size of a period on a printed page, Alpha Centauri would be about 14 kilometers away. Because it works so hard, the sun will eventually burn out. The sun's been doing its thing for about 5 billion years. It'll probably do it for another 5 billion. At the end of its life, the star that nurtured us for so long will care little for us. The solar wind will become a cyclone that may even evaporate the atmosphere. The sun, as other stars have done, will explode into a supernova, eventually spinning itself into a neutron star. There is a bright side. The heat from the sun dying may be warm enough to melt the water-rich but frozen moons of Jupiter and Saturn. We humans, if we're still around, might relocate there.